Hi there, students. So I know that Mr. Tomlinson took you through a detailed explanation of the sine and cosine graphs, and now I'm going to do some other trig graphs. I'm going to start with tangent. So we know from the unit circle that tangent of theta is the same as the slope of this line because I can think of it as the y value over the x value. So notice my slopes. Well, if I start at theta equals 0, that's a slope of 0. As I get up towards pi over 2 radians, my line is now vertical, so my terminal side would be up here, and I've got a vertical line which has a slope that's undefined. So I'm going to come in, I'm going to call this pi over 4, and then pi over 2. So undefined, I'm going to put in an asymptote. And then I'll say that'll be 3 pi over 4, and then pi. So at 0, we said that the tan value is 0 because I have a horizontal line. At pi over 4, well, that's here. And we know that pi over 4, that's our same. So that slope is 1. So let's call this 1. So between 0 and pi over 4, I have values that are all less than 1 but are increasing. So I look like this. And then I just continue to increase until I go towards infinity. Now on the other side, as I go this direction, if we go to 3 pi over 4, well, that's over here. Again, I've got my same, but now I've got a negative slope, and in fact, it's -1. So 3 pi over 4, I'm at -1. And let's think about just right here, just after we cross pi over 2. Well, I've got a line that's almost vertical, but with a negative slope. So I'm going to be coming from this side of my asymptote. And then I'm going to continue decreasing. That is not looking very well. That is not what I want it to look like. Apparently I can only draw it from one side, so I have to keep talking about it so that I can draw the whole thing. All right, so we're going to keep going down. At pi radians, we're horizontal again, so a slope of 0. As we continue, if I hit 5 pi over 4, that's again where I've got my same, but now I've got a positive slope because this is my negative over negative. So at 5 pi over 4, I'm back at +1. So I'm doing something like this, where I'm getting, my function is constantly increasing, coming from a very low negative. So if I think about going on to this side, well, this is where my thetas are negative. So if we go to -pi over 4, well, that's the same as coming down here. And now I've got my negative slope, my slope of -1. If I continue going negative until I hit pi, sorry, I can't just blow through this. If I go to -pi over 2, that's a vertical line with a slope of 0. Sorry, a vertical line with a slope that's undefined. So that's an asymptote. So I continue decreasing until we hit -infinity. So my curves are not very smooth. Let's jump into Desmos so that we can look at something prettier. So in Desmos, let me make a new one. Okay. So I'm going to do y equals tan of x. So now x is going to be my angle in radians. And I want to show you something cool on Desmos too, that if you're graphing things and want to check your answers. So I'm going to do y equals tan of x. Desmos is sophisticated mathematicians. It defaults to radians. But I can also come in here and say, please count using pi values or pi over 2 values. And I can stretch this out. And so there's the shape of my curve. And we can see that we're 1 at our pi over 4 values. It doesn't draw in our asymptotes. If I was going to draw in the asymptotes myself, well, let's think about that. I'm going to say that my asymptotes are at pi over 2, 3 pi over 2. We had -pi over 2. If I continued around, I would hit 5 pi over 2 or negative 3 pi over 2. Well, notice these are all starting at pi over 2 and then adding multiples of pi. So I add pi or I subtract pi. So my asymptotes are going to be not x. Theta is pi over 2 plus multiples of pi, where k is an integer, and positive or negative because I'm going either direction. So let's think about this. If I think about my transformation, vertical stretch, horizontal shift, vertical shift, my domain is going to be, so now my angle is, I'm calling my angle x. So for the original one, my domain would be x is an element of reals, x is not equal to pi over 2 plus k over pi multiples. Well, if I horizontally shrink my graph, horizontally shift my graph, I'm going to take my period, which is normally pi, but I'm going to divide it by the b value. So if I shrink it, I'm bringing my asymptotes in. And if I then shift it left or right, my asymptotes would also shift. So I'm going to take my pi over 2 plus k pi. So x is all reals, except x is not equal to pi over 2 plus k pi. But all of that would have to be divided by b and then shifted left or right by my c value. This is a lot to think about. We'll come back to this later. Right now, our basic domain is this one. Range, well, that's always going to be all reals. The phase shift is going to be my c value. So we're going to move things left and right by c. My amplitude, well, it's not the same as sine and cosine. Really, I see the amplitude most clearly at sort of the quarter marks of your period. So that's normally where it would be 1. But my amplitude, I'm going to call A. So let's look at one graph, and then I'll stop this video and come back with another. So tan 2 tan x minus 1. Well, this one's easy because I'm just doing everything to the vertical values. So my asymptotes are going to remain as, so I'm going to call that pi over 4, and pi over 2 will still be my asymptotes. And then I'll have pi over 4, negative pi over 2. Okay, so normally we would go through the point 0, 0. Now we're still going to go through 0, but I'm going to multiply by 2 and subtract 1. So that's going to be sort of the middle of my graph. So if we call that 1. And then normally we would go to the quarter point and go up 1. Sorry, that's negative 1. But now we're going to double that. So go to the quarter point and go up 2. Go to the quarter point and go down 2. I can also think of that as normally we go through pi over 4, comma 1. Well, we're not changing anything with our x values. My y values, I'm going to multiply by 2 and subtract 1. So 2 times 1 minus 1 is positive 1, which is where I put it. I could say the same with pi over 4, negative pi over 4, negative 1. So I'll still be at negative pi over 4. 2 times negative 1 minus 1 is my negative 3 down here. So I can draw that in. So my center point is where my concavity changes. I go from concave down to concave up. And I can just repeat this over and over again. So I'm going to think about quarter point, negative 3, midpoint, negative 1. So I'm going up this way. That's where my concavity is going to switch. So sort of like that. And at this point, I start curving the opposite direction.